Hi, this is Mr. Mac. Now this concept video basically deals with dividing one polynomial by another polynomial. Now, there are three things that I want to get taken care of in this concept video. I want to talk to you all about dividing a polynomial by a monomial. Now, a monomial is a polynomial that has one term. One term, there's no plus signs or minus signs. 7x is a monomial. 19x squared y cubed is a monomial. But something like x plus 3 isn't a monomial because of the plus sign. There's two terms there. X is a term and 3 is a term. So first of all, we want to take care of dividing by a monomial. Now secondly, we want to talk about dividing a polynomial by another polynomial, and this entails polynomial long division. Now, I'm going to use numeric long division as kind of a framework to help you understand what it is that you're doing in polynomial long division. And I know that long division is just near and dear to your heart, so I'm sure you're going to enjoy that. But no, actually, it's not as bad. Polynomial long division is not as bad sometimes as numeric long division. And then, almost right off the bat, we're going to give you a shortcut method to do division. It's called synthetic division. Now, synthetic division will work sometimes, and other times it won't work. So we'll talk about when it will and when it won't work. And when it does work, we'll be very happy to have it. Okay, so first of all, let's handle dividing a polynomial by a monomial. Now, that would be something like this problem here, where you have 27x cubed y squared minus 63xy cubed plus 45x squared y to the fifth, and you're dividing that by 9xy. Now, 9xy doesn't have a plus or a minus sign in it. It's one term. So what you can do is you can think of that as a fraction, this three-term polynomial divided by the one-term polynomial, and since the denominator is just one term, you can think of 27x cubed y squared being over 9xy, and then you can think of negative 63xy cubed also being over 9xy, and finally you can think of 45x squared y to the fifth also being over 9xy, and then just do the division for each term. Now, in this term, we can group things together that we can divide. 27 divided by 9 is 3. X cubed divided by x is x to the 3 minus 1, or x squared. Y squared divided by y is y to the 2 minus 1, or y to the 1. And then we have minus. Now 63 divided by 9 is 7. X divided by x is 1. 7 times 1 is still 7. And y cubed divided by y is y squared. And then plus 45 divided by 9 is 5. X squared divided by x is x. And y to the fifth divided by y is y to the fourth. And that's basically division of a polynomial by a monomial. Now, if you have a complicated monomial term, there is a temptation perhaps to say, oh, well, I better do polynomial long division with this, but you don't and shouldn't use polynomial long division if all that you have is a monomial divisor. Now, let's go to number 2 on our list, dividing a polynomial by another polynomial that's not a monomial. Now, what we're going to do first is we're going to take a look at a long division problem. Now, I've specifically selected this long division problem because it illustrates everything that we're going to be doing. And even though there are more problems that sometimes crop up in long division problems, numeric long division problems, this one doesn't have any of those problems. So if this problem doesn't exhibit it, then you're not going to have to worry about it. So we're going to divide 21 into 883. Now, the way you should have been taught to divide the algorithm would be to look at the first number of the divisor, in this case the 2, and the first number of the dividend, in this case 8. And you ask yourselves, how many times does 2, you ask yourself, how many times does 2 go into 8? And the answer is 4. So you put the 4, since we've got a 2-digit divisor, we put the 4 over the second digit of our dividend. And then you multiply. 4 times 1 is 4. 4 times 2 is 8. Now at this particular point, you're supposed to subtract 84 from 88. 8 minus 8 is 0, and 8 minus 4 is 4. Now, continuing the problem, you would bring down the 3, and you would again look at the 2 in the divisor, the 21, and the 4 in the number that we have down below the line, and you ask yourself, how many times does 2 go into 4? That's this question, and the answer is 2, so you'd put the 2 one space over from where you put the 4 before. Now you multiply the 2 by the 21. 2 times 1 is 2, 2 times 2 is 4, and once again you subtract. 4 minus 4 is 0, and 3 minus 2 is 1. Now, at this particular point, you really have 3 different choices. One choice is to write R1. Now, we're not going to do that. The second choice would be to put a decimal and add zeros and keep going. You know, bring the decimal up and keep going and get a decimal expansion. We're not going to do that either. And your third choice was to take the number that you have down here and put it over the divisor as a fraction. So in other words, 1 over 21. Now this is 42 and 1/21. It's kind of important also to know that the operation symbol in here is actually a plus sign. See, in algebra, if you put two things together like x and 2, that 2x, that means to multiply. But when you put the 1 over 21 next to the 42, that means you're actually adding. So when we do polynomial long division and we have that fraction, you must put the plus sign in, because in algebra, if you don't put a plus sign, you're saying, and this is multiplication, and it's not, it's addition. All right, now, this is the division problem that we're going to use kind of as a framework to understand polynomial long division. I'm going to move this away here. And I'm going to move these away as well. We don't need any of that. And I'm going to group this all. And make it a little bit smaller up here in the corner so that we have enough, lots of room. Now, what we'd like to do is we'd like to divide x minus 2 into, okay, I had to pause the video for a second to answer the phone, and now I'm back. Now, what we want to do is we want to divide x minus 2 into the polynomial x cubed plus x squared minus 13x plus 20. Now, looking at the framework that we have, we're going to do pretty much the same thing. We look at the, okay, now first of all, both the divisor and the dividend, the x minus 2 and the x cubed plus x squared minus 13x plus 20, need to be written in order of decreasing powers, and if there are any power terms missing, you need to put a 0 in that place as a placeholder. See, now, once you've done that, you look at the first term of the divisor and the first term of the dividend, and you say to yourself, how many times does x go into x cubed? Now, if you look at this, x cubed divided by x, we know that when you're dividing, the base is the same, you subtract the exponent. So x to the 3 minus 1 is x squared. And that is how many times x goes into x cubed. Now, the x squared gets put in what I would like to refer to as the x squared column. In other words, since we've got a two-term divisor, we put the answer to that question second term over. Now, we want to, I'm going to erase this, and this, and this. Now, we want now to multiply this x squared by the x minus 2. X squared times negative 2 is negative 2x squared, and x squared times x is x cubed. Now, in our framework, we want to subtract. As a teacher, I have seen students time after time after time make a mistake on this because there are negative signs here that are just reaching out to trip you up. But I found that a lot of less mistakes get made if you look at the second polynomial. In other words, look at this polynomial right here, and you realize you want to subtract that polynomial from the one above it. So what we do is we distribute a negative sign through this polynomial and then add. See, adding a negative is the same thing as subtracting, but if you distribute that negative sign through, in other words, you make one mark on each term in the polynomial you're subtracting and add, then you will not make as many mistakes. Now, x cubed plus negative x cubed is 0. Now, that doesn't always have to happen in long division, but it does always have to happen in polynomial long division. And notice I made sure that that happened every time over here too in the example or the framework that I gave us. And then x squared plus 2x squared is 3x squared. See, that's where a lot of times the mistake is made, and you have a chance to make that mistake over and over and over again. And as soon as you make it, when you're building off of that number, everything else is going to be wrong. So really, you need to be very careful to get these right. Now, the next thing we did was so we would bring the next term down. So we'll bring down a minus 13x. And once again, we look at the first term here, and we look at the first term here. And the question is, how many times does x go into 3x squared? Well, obviously, it goes in 3x times. So we'll put the 3x, positive 3x, up here. Once again, we multiply. 3x times negative 2 is negative 6x. 3x times x is 3x squared. Now, once again, we want to subtract. Let's get rid of this. Want to subtract, so we'll distribute a negative sign to each term of the polynomial we're subtracting, and then we'll add. 3x squared plus negative 3x squared is 0, and negative 13x plus 6x is negative 7x. Once again, bring down the next number, so we have plus 20, and we look at the x, and we look at the negative 7x, and we ask ourselves, how many times does x go into negative 7x? And the answer is negative 7. So we're going to put a negative 7 right here. Once again, don't need that anymore. We'll multiply. Negative 7 times negative 2 is positive 14. And negative 7 times x is negative 7x. Once again, distribute a negative sign through the terms of the polynomial we want to subtract, and then we'll add. So we get 0 here again, and here we get plus 6. Now, we're down to the point where we don't have anything else to bring down. Remember what I said we were going to do. We're going to take this number 6 and put it over the divisor, x minus 2, and make it a fraction. So it's 6 over x minus 2. But it is important, and I will take a point off if you don't put this. It is important to say that that's addition, because if you just had the 7 and then the fraction, algebraically that would mean multiplication, and that's not right. And that is polynomial long division. Now, the last thing we want to handle is synthetic division. Now what I'm going to do, I think I've got everything here, is I'm going to make this smaller and put it over on the side. And we're going to go ahead and we're going to do this problem again, but this time we're going to do synthetic division with it. Okay, now synthetic division is, let me just write this, synthetic division. is kind of a formalized way to do polynomial long division when the divisor is linear. Now, you cannot use synthetic division unless you have a linear divisor, and that means that the degree of the x term is 1. In other words, it's just x to the 1. And we need x to have a coefficient of 1. Now, if we don't have a coefficient of 1 in our divisor, we can handle that. And we'll talk about how to handle that in a few minutes, or it'll be in a couple of the solution videos. But it is important to realize that you've got to have a linear divisor and the x needs to have a coefficient of 1. Now, both of those things actually have occurred in this problem already. So we can just go ahead and do synthetic division. And just to make myself some room, I'm going to make this small, move that over there as well. All right, now, here's how you do synthetic division. First of all, you put a little half square, and in that is going to go our quote divisor. What we actually put in there, see, again, what we're dividing is x minus 2 into x cubed plus x squared minus 13x plus 20. What we do is in this little half square, we put the 0 of the divisor. Now, the 0 of x minus 2 is 2, because that's the number that you could put in for x so that x minus 2 would be equal to 0. Now, to the right of the little half square, we put the coefficients of all the terms in our divisor. In that case, it's going to be 1, 1, negative 13, and 20. Now, if any of the degreed terms are missing in the divisor, you must put a 0 in that place. If you don't, you will get what we refer to as the wrong answer. Got to have a placeholder for any term that's missing. Now, also, please remember that this 1 right here represents the coefficient of the x to the third term. And that'll be important in a moment. Now, to do synthetic division, we draw a line below the numbers that we've written, far enough down so that there's room above the line for numbers and room below the line for numbers. And then be careful, this is going to happen real quickly now. We take the first number after the little half square and we put it below the line. Now, if you have, we'll also put a little dotted line here. The reason for that will become obvious in future lessons. If you have a number below the line, you multiply it by the number in the half square and you put it above the line next spot over. So 2 times 1 is 2. If you put a number above the line, add it to the other number above the line and put the answer below the line. So 1 plus 2 is 3. Now, since we have a 3 below the line, 3 times 2 is 6. It goes above the line. Since we have a number above the line, negative 13 plus 6 is negative 7. Since we have a number below the line, 2 times negative 7 is negative 14. We put it above the line. 20 plus negative 14 is 6. And we're done, except for interpreting. Now, in synthetic division, since the divisor must be linear, the first number that we have down here represents x to 1 power less than the one that we put in. See, x cubed becomes x squared. 2 is 1 less than 3. And then the others decrease in power. So we would say the answer is 1x squared plus 3x minus 7, and then this little 6 that's over here is the remainder. So we put plus 6 over the divisor, which is x minus 2. Now, that was really pretty easy, and look at this. Compare it to this. Now, is that not cool? Now, you can't do that unless you have a linear divisor and unless you have a coefficient of 1 in front of the x squared. Now, let's go ahead and do one problem with synthetic division where we don't start with a 1 in front of the x. So let's try 6x cubed plus 4x squared minus 12 divided by 2x plus 4. Now, if we want to divide 2x plus 4 into 6x cubed plus 4x squared minus 12, we can see that 2x plus 4 is a linear divisor. Its degree is 1. There's an exponent of 1 on the x, and then the 4 is a constant. So it's got a degree of 1. It's a linear divisor. But we don't have a coefficient of 1 in front of the x. So what I want to do is I want to multiply 2x by 1/2 so that I'll get a 1 in front of it. So I'm just going to go ahead and do that. But the only way I can actually do that is if I multiply the numerator by 1/2 as well. You see, what I'm doing here is I'm really multiplying by 1 and changing the form of this fraction so that it will be one that I can use synthetic division for. So 6x cubed times 1/2 is 3x cubed. 4x squared times 1/2 is 2x squared. 12 times 1/2, or negative 12 times 1/2 is negative 6. Now in the denominator we get x plus 2, because 2x times 1/2 is x, and 4 times 1/2 is 2. So now we're ready to do synthetic division. Inside the half square, I'm going to put, pause here for you to decide, pause the video if you want, and we're back, negative 2, because negative 2 makes x plus 2 equal to 0. Now, the numbers over here are going to be, pause again if you wish, 3, 2, 0, negative 6. Now, if the 0 surprised you, you need to go back and listen to the part where I was talking about synthetic division again. We're missing the x term here. There is no x term, so you have to put in a placeholder of 0 for it. Then draw your line and begin. 3 goes down here, we get negative 6 up here. Negative 4 goes down here, we get 8 up here. 8 goes down here, we get negative 16 up here. When we add, we get negative 22. So the answer is going to be, and remember again, this was the 3x cubed, so this is going to represent the x squared coefficient. So we get 3x squared minus 4x plus 8 plus negative 22 over x plus 2. And that is synthetic division. So we're done.